All right, Algebra 2, this is a continuation of functions. This is on quadratic functions. So on this graph, this is the shape of a quadratic function, so it should look familiar. It's a parabola. All right, and so the most common vocabulary terms that you'll need to know are what's called solutions or zeros, roots, or x-intercepts. So they all mean the same thing, and how we find them are really the same. So they just ask it in different ways, but just know that they really all mean the same. So if you can figure out how one of them works, then the other ones work the same way. So the equation that's shown is y equals x squared minus 2x minus 8. So this equation is a little different than when we did linear ones, because this has an x squared term. And because the highest exponent in this equation is a 2, exponent 2, that means this is called a quadratic function. It's not linear anymore. All right, so if we use this equation that's on the left side, we can answer each of these questions. It says x-intercepts are the points where the graph touches the x-axis. What are the x-intercepts of the graph? So we can see where the graph crosses the x-axis, here at +4, and then again at -2. All right, so the order doesn't matter, but -2 and also +4, those are called the x-intercepts. Now zeros and roots are generally used with function notation like f of x. They're the x values that have a y value 0. Again, that's how you find x-intercepts. So again, this point right here, -2, since it's the x-intercept, its point is actually -2, 0. It has a y-intercept that's 0, y value 0. Okay, and then 4 is really just 4, 0. All right, so which x values have a y value 0 on the graph? Again, it's just the -2 and the +4. Okay, those two have a y value 0. Again, those are called the x-intercepts or zeros or roots. All right, so it says, what do you notice about the x-intercepts, zeros, or roots? They all are the same. Okay, so it's where the graph crosses the x-axis. All right, so then we can answer some of these questions down here. Find the value of the function f of 2. So f of 2 means when x is 2, what's its y value? Okay, so if we go to the x-axis, +2, +2 is right here. Now, all you're going to do is go up or down and find out where does it intersect the graph, okay, with +2. We can see if we go down, there's a point there. This point right here is 2, -8, looks like. So that means if its x is 2, its y is -8. So that means that f of 2 is -8. All right, so f of -1. So we'll go to the x value of -1, and again, we want to find the y value. All right, so when x is -1. So here's -1. Here we have to go down. All right, and we can see the point right here. This is -1, -5. And so that means when x is -1, it has a y value that's -5. All right, and then find the x value. So f of x equals -8. So this is just the reverse. So this is our y value. We're looking for the x value. So if y is -8, now we go to -8 on the y-axis. All right, and we can see that that point is 0, -8. So when y is -8, x has to be 0. Right, so that means x equals 0. Because the question is, find x. X is 0. All right, factoring. All right, so there's a lot of different factoring that we're going to do. We have quadratic factoring, we have polynomial factoring, and factoring comes in a lot in the next couple of units also. So all that factoring that you did in Algebra 2 and Algebra 1 come back again, and so we're just going to relearn it, review it. I'm going to show one way to do the trinomial factoring, and if you want to use a different method that you maybe learned or remember from your other teachers, then go ahead and use that method. I'm just showing you one method. As long as you get the same answer, then it's fine. All right, so when we factor, the first step, always look for greatest common factor, GCF. So if we have the equation 6x squared plus 8x, the GCF, or greatest common factor, that goes into both terms is 2x. All right, so we can factor 2x out, and so then we divide. Okay, now if you divide by 2x on both of them, and if you simplify them, you'll get 3x, or 6x squared divided by 2x. You get 3x left over, and then 8x divided by 2x simplifies to 4. And so that's why inside the parentheses it's 3x plus 4. And if you were to distribute this 2x back in, you'll get back the original 6x squared plus 8x. So you know that it works. All right, step 2, if there's no GCF, we want to look and see how many terms there are. Well, if there's 2 terms, after we pull the GCF out, we want to look and see what's called the difference of squares. So here's an example, x squared minus 9. This is called the difference of 2 squares. So difference means subtraction between the 2 terms, and both terms are perfect squares. So when we have that, it's going to factor into 2 binomials, 2 terms. And then what we do is we take the square root. Okay, if we remember square roots, the square root of both terms. So the square root of x squared is x, so we write that twice, x and x. And then the square root of 9 is 3, 3 and 3. All right, and then we just make sure we put one as a plus sign and one as a minus sign. So it's always plus and minus. So x plus 3, x minus 3. All right, let's see, step 3, if we have 3 terms, okay, that's called a trinomial, 3 terms. So again, we look for greatest common factor if we can pull that out first. Then we look and use the x factor, okay, x method for factoring. So for example, x squared minus 2x minus 15. All right, so our general form in a trinomial is ax squared plus bx plus c. Now, the first one we're going to look at is when a is 1. So the first term is positive 1. So what we always do is you multiply the a term times the c term. That gives us the top number. Right? So in this first example, x squared minus 2x minus 15, there's a 1 really in front of that x squared. So 1 times negative 15 is negative 15. So that's why we have a negative 15 on top. And we do this x. The middle term is negative 2, and that goes on the bottom. All right, so now we're looking at 2 terms, trying to find 2 terms that multiply. All right, so it has to multiply to negative 15, but add to negative 2. And so the combination is negative 5 and 3. So negative 5 times 3 is negative 15, and when you add negative 5 plus 3, you get negative 2. All right, and so then we have our 2 factors, negative 5 and 3, and so you can see x and minus 5, x plus 3, those are the 2 binomials. All right, now, before we get to this, this next one, when a is not 1, all right, I want you to see really what we're doing, so you can just memorize this pattern if you haven't seen it before. You call it bottoms up or trash method. But because our a value is positive 1 in this example, really what we're doing is we're taking it and dividing it, those 2 terms, negative 5 and 3, by 1. That's just because the a value is 1. And if you simplify those fractions, you just get back negative 5 and positive 3, and just gets back to the normal, and there you go. You get your binomials. So when we do this next one, again, we look for GCF always. But here the a value is not 1. A is not 1. Okay, in this example, a is positive 3. 3x squared plus 4x minus 4. So here we have to multiply the first and last. We get negative 12. 3 times negative 4 is negative 12 on top of our x. And our middle term is 4. That goes on the bottom. So we're looking for 2 numbers that multiply to negative 12 but add to 4. All right, so that's going to be positive 6 and negative 2. 6 and negative 2 multiply to negative 12 but add to 4. But now what we're going to do is take this 3, since we're leading off with a 3, and that's going to go on the bottom of both terms. Okay, so we divide 3, okay, from the 6 and the negative 2. Now, if either fraction can simplify, you have to simplify the fraction. Well, 6 divided by 3 does simplify. 6/3 is the same as 2. Okay, but negative 2/3 doesn't simplify. So now when we write our 2 binomials, we have the x plus 2. X plus 2, that's from the 2. And then the 3x minus 2, this is where the bottoms up comes from. This bottom number 3 comes up next to the x. Okay, and then the numerator minus 2 goes off to the side. So 3x minus 2. All right, and that's how you factor those. I know there's a grouping method that you could use, and it starts off the same way. Okay, so I'll just show it real quick. If you want to use this, you write the first term, 3x squared, and then the last term, minus 4. And then you use your two numbers from your x, 6 and negative 2. Okay, so you put plus 6x and then minus 2x. And then you group. All right, so you group the first two, group the last two, and you pull GCFs out. So 3x is the GCF of the first two, and you have x plus 2 left over. And then you want to factor a negative 2 out, and you have x plus 2 left over. And then this finishes by our two binomials. Okay, the outside terms, 3x and negative 2, go in one set of parentheses, 3x minus 2. And then what's duplicated, x plus 2, that just goes in one set. So you don't write it twice, you only write it once. All right, and so you can see it's the exact same answer that we got before. It doesn't matter which method you use, but if you're more familiar and more comfortable using grouping, then use grouping. And if you've seen this X and bottoms up method, then use that. When I factor, I will use the bottoms up method just because I think it's a little bit easier and it's faster, less writing, since you're already doing the X. And most of the work is already in that X method. All right, so let's go ahead and practice factoring each of these. All right, so we have two terms, and we want to look for a GCF. That's the first step. And so a 3 and a 12, I know 3 goes into both of them, and then they both have x's, so that means I can factor an x out. So the GCF is 3x. Now I divide each of them by 3x, so 3x squared divided by 3x, I'm left with x minus, and then 12x divided by 3x, I'm left with 4. And that's as far as I can factor. 3x, x minus 4. Again, if you wanted to double check to see if you were right, you can distribute back in and see if you get the same answer. All right, so let's go ahead and try B. Again, we have two terms, so we want to look for a GCF. And so we have a 2 and a 50. And since they're both even numbers, we can factor a 2 out. And so we divide both of them by 2. We don't want to factor an x out because they both don't have x's. So we have x squared minus 25. Now x squared minus 25 is a difference of squares. Difference of squares. So that's going to factor into two more binomials because we can square root both of those terms and there's a minus sign. So when we square root x squared, we have x and x. And square root 25 is 5. And 5, and we put a plus and a minus. And then this 2 that we pulled out at the beginning has to go down in front. Now this is factored all the way. All right, C, there's a trinomial, 3 terms. There's no GCF, nothing goes into all 3 of those terms. They all don't have x's. Nothing goes into 1, 9, and 18. So we'll go straight to the x. All right, now 18 goes on top and 9 goes on the bottom. And we need two numbers that multiply to 18 but add to 9. And so that's going to be 6 and 3. 6 times 3 is 18. 6 plus 3 is 9. Since we're leading off with a 1, we don't have to divide by 1 because 6 divided by 1 still stays as 6. So we write our two binomial parentheses. We have an x plus 6 and an x plus 3. All right, and then D, let's see, we have a trinomial. There's no GCF, so we'll go straight to the x. All right, and so again, here we're going to multiply 2 and negative 15 together. That goes on top, that's negative 30. And the middle term is negative 1. So we need two numbers that multiply to negative 30 but add to negative 1. So it's going to be negative 6 and positive 5. Now, because we're leading off with a 2, we have to divide by 2 if this is the method you're using. Okay, again, if you want to use grouping, then use grouping. All right, so negative 6 divided by 2 will simplify to negative 3. Let's see, positive 5 over 2 doesn't simplify. So now we'll write our two parentheses. Our first one, we'll just write x minus 3. The second one, at 5 over 2, the 2 has to come up next to the x. So it becomes 2x. And then the numerator, plus 5. It's positive, so it's plus 5 at the end. All right, and so that's factored all the way. Okay. All right, now if we want to solve a quadratic equation, we want to make sure the equation is set equal to 0. And then there's this zero product rule that says that if you have two factors, A and B, then and it's equal to 0, then either A equals 0 or B equals 0. So when we're asked to solve a quadratic equation, the first thing you want to do is write the quadratic equation in standard form, okay, and it's set equal to 0. Okay, so highest exponent down to lowest. All right, so again, standard form ax squared plus bx plus c equals 0. And we're going to factor it using one of the methods that we just used, and then we'll apply this zero product property rule to solve it. All right, so let's go ahead and solve each of these. So the first thing we have to do is make sure the equation's equals 0 and it's in standard form. I'm going to subtract 18 over first. All right, so x squared plus 3x minus 18. There's no like terms. We can't combine anything together. I have a trinomial, so I'm going to use my x. Negative 18 goes on top and 3 goes on the bottom. So two numbers that multiplied negative 18 but added 3. 6 and negative 3. I'm leading off with a 1 in front of that x squared, so I don't have to divide by 1. So the factors are x plus 6, x minus 3 equals 0. Okay, so I factored it. Now I'm going to solve it. So to solve it, I said x plus 6 equals 0, and x minus 3 equals 0. This is where that zero product property rule comes in. So now I solve it, I can subtract 6 over. That means I'm getting x equals negative 6. And then on the other one, I add 3 over. X equals positive 3. So those are the two answers, negative 6 and positive 3. All right, number 2. Let's see, I have to add 5 over because it's not equal 0. So I have to do the opposite. So add 5. There's no GCF, so I'll go straight to the x. I have to multiply 4 and 5 together. That's going to give me 20 on top and then negative 12 on the bottom. And so the combination that works for this, let's see, it's negative 10 and negative 2. That multiplies to positive 20 and adds negative 12. Now, because I'm leading off with a 4, I have to divide by 4 on both of them. I have to simplify also. Negative 10 over 4, that's negative 5 over 2. Negative 2 over 4 is negative 1 over 2. All right, so then my factors, bottoms up. The bottom number comes up next to the x, 2x minus 5. And the other one, 2x minus 1 equals 0. So now I'm going to set those equal to 0 and solve. Okay, so 2x minus 5 equals 0. 2x minus 1 equals 0. So here you have to add 5 over first, add 5, and then divide by 2. So that's 5 over 2. And then the other one, you're going to add 1 over. So that's positive 1, and then divide by 2. 1/2. So the two answers are 5 over 2 and 1 over 2. All right, number 3. Let's see, we have two terms. It's already equal to 0. So we're going to just look for a GCF to start it out. 4 and 10, they're both even numbers, so 2 can factor out. And then they both have b's, so we're going to pull the b out also. So now if we divide each of those by 2b, we should have 2b and then minus 5 equals 0. All right, now we're going to set each of those equal to 0 because it's factored all the way. 2b equals 0 and 2b minus 5 equals 0. All right, so on the first one, we just divide by 2, and 0 divided by 2 is 0. The other one, we're going to add 5 over first, and then divide by 2. And so it's 5 over 2. All right, so 0 and 5 over 2 are both answers. All right, and then number 4, a lot of room here, see if I can squeeze it in. Let's see, two terms. I have a GCF. I can pull a 2 out. So I'm going to pull the 2 out. I have d squared minus 1. D squared minus 1 is a difference of squares because there are two terms. I can square root both of them, and there's a minus sign. So I'm going to go ahead and factor that into d plus 1, d minus 1. Sorry. My computer doesn't like when I move over to the edge. Let's see if I can squeeze it in here. Equals 0. All right, so then since 2 doesn't have an x or a d with it, a variable, then we can ignore the 2 as far as trying to find the solution. But d plus 1 has a variable, so we have to set that equal to 0, and then d minus 1 also. So here we're going to get d equals negative 1, and then d equals positive 1. And then the 2 out in front, since again there was no variable, we can ignore the 2 for trying to find the solution. All right, let's see. If you're asked to find the zeros of a function, just replace the function f of x with 0 and then solve it. So for example, if the question says find the zeros of f of x equals 3x squared minus 75, that's the same thing as saying 3x squared minus 75 equals 0. All right, so just set the equation equals 0 and then go ahead and solve it. So here what I can do is I have a 3 and a 75, and I know there's a GCF of 3 that goes into both of them. And then x squared minus 25, I can square root both of those terms, so that means it's a difference of squares. So x plus 5x minus 5. And then I can set each of those equal to 0. Again, the 3 doesn't have an x, so I can ignore that. But the x plus 5 and x minus 5 do. So if I solve it, I'm going to get x equals negative 5 and x equals positive 5. All right. And if you kind of see the pattern in these, and this is going to come into play when we get to polynomials. The highest exponent in all our problems for quadratics is 2. Okay, exponent 2. And if you look at all our solutions, there's always 2 solutions. And that's going to come into play again in the polynomials in the next lesson. But in the degree is, or the highest exponent, we'll talk about degrees in the next lesson, but when the highest exponent is 2, it means there's two solutions. All right, now we're going to graph a parabola. This is just one of the different, there's like 3 different methods on graphing. I'm just showing you one of them. So all quadratic graphs have a shape of a U. Again, they're called parabolas. So our standard form, when we graph, y equals ax squared plus bx plus c. If the a value, that's the number in front of the x squared, if it's positive, the graph is going to open up. And if a is negative, it opens down. All right, so opening up looks like this. Opening down looks like that. We have what's called the vertex. The vertex is either the highest or the lowest point on the graph. And so for each of these, I'll point it out. Okay, highest point or lowest point. That's called our vertex. It's an ordered pair. And so to find it, we always use the formula x equals negative b over 2a. That's going to get us the x coordinate. And then we substitute that into the equation, back into the original equation, and that'll get us the y coordinate of the vertex. All right, so here we're going to find the vertex, and we're going to graph the equation also. So I'm going to show you a shortcut on getting a couple points on your graph also. All right, so our vertex, we have to use negative b over 2a. So if you look at this in standard form, a is the 1, b is 4, and c is negative 12. Now we're not going to use the c value right now for the vertex though. We just use the a and the b. So x equals negative b over 2 times a. And so it's negative 4 over 2, and that's negative 2. So when we state what the vertex is, the x coordinate is negative 2. Now to find the y coordinate, we're going to take negative 2, and we're going to substitute that back in to all the x's. And if you have a calculator, it makes it a little easier. All right, so the y coordinate is negative 2 squared. Make sure you put parentheses because we're squaring x. So negative 2 needs to be in parentheses. Because then we want that to be, it's going to end up being a positive 4, not negative 4. plus 4 times negative 2 minus 12. All right, so this is 4 minus 8 minus 12, order of operations, negative 16. So vertex, negative 2, negative 16. So we're going to plot that. So here's negative 2. We're going to come down here to negative, we'll say that's negative 16 down there. All right. Now, because the A value is positive, it's positive 1, the graph's going to open up. It's a U shape. Now, to get a couple more points, we can use that A value and kind of use slope. It only works for 2 points. You can't use it continuously. It only works for the first 2 points. So what we're going to do is, since the A value is 1, what we're going to do is go up 1 and then right 1 on our graph and put a dot. And then up 1, left 1 and put a dot. All right? And then if we connect them, it'll kind of look like this. All right, so it's this U shape. The big one up. All right, B. Let's see, let's get our vertex. So here A is 2, B is negative 4, and C is negative 1. So using x equals negative b over 2a. So here we have a negative negative 4, which is positive 4, over 2 times 2. 4 divided by 4 is 1. So the x-coordinate of the vertex is positive 1. Okay, now we plug 1 in for x, and you can plug it into both of them. Again, if you want to use your calculator, it's fine. And then find the y-coordinate. So let me do it here. So y equals 2 times 1 squared minus 4 times 1 minus 1. So order of operations, exponents first. 1 squared is 1 times 2 is 2 minus 4 minus 1. And then 2 minus 4 is negative 2 minus 1. And that's negative 3. So positive 1 and then negative 3. It's right there. So there's the vertex. The A value is positive 2. It's going to go up. And then again, use that A value. You can go up to right 1, up to right 1, put you there, and then up to left 1. It's going to put you right there. And then we have our graph. Okay, up to right 1, up to left 1. All right, and then this last one, C. A is negative 3, B is 6, and C is 2. So x equals negative b, negative 6 over 2 times negative 3. So negative 6 over negative 6 is 1. So the vertex is 1 comma something. So let's plug 1 in for all the x's. All right, so let's see. Negative 3 times 1 squared plus 6 times 1, and then plus 2. Plus 2. All right, so that's negative 1 squared is 1, and then times negative 3 is negative 3 plus 6 plus 2. Negative 3 plus 6 is 3 plus 2 is 5. So this has a vertex of 1, 5. Positive 1, 5. It's right there. Now, our A value is negative 3. The graph is going to point down because A is negative. So what we're going to do is count down 3 and then left and right 1. So 1, 2, 3, left 1, 1, 2, 3, right 1, and then connect them. All right. Again, you can only do that on those first 2 points going using slope. It's like slope. That's called the vertical stretch and shrink of the graph. So you can only do it one time, going left and right though. Make sure you point in the right direction, either going up if A is positive or down if A is negative. All right, again, if you have any questions, send me an email, or you can go on Zoom during the Zoom meeting time. All right, so good luck, and if you need to see this video again, go for it. All right, bye.